let's play a game. And this game is called Protein Sequencing 101. And it literally is a mind game. That's what these problems are. They want you to kind of take a look at the information that's given and put all of the pieces together, because this is typically what's done in a laboratory environment, and it's very important for us to understand really the purpose of these reagents and what kind of information that they're providing. So here's an example problem, and the example problem says you have a nonapeptide. Now, you probably can't go very far with the problem if you don't know what nona means. So if you go back to CTC 120, this was your very first organic class, and maybe even earlier, back in CTC 111, your very first chemistry class with us, we went through what these prefixes stand for. So di, tri, tetra, penta, hexa, hepta, octa, nona. So nona was the definition for 9. That was the prefix that was used. So this means that this is a nonapeptide. So there's 9 amino acids in this peptide that we are analyzing. So that's kind of the very first thing that I do. I come down here and I do 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, so there's 9. It at least gives me a starting place. And this sets up the game of hangman in a way, right? And it's my job to figure out what amino acids go in what order. That is what this problem wants you to focus on. Okay, so a nonapeptide undergoes partial hydrolysis. So this probably means it's not going to fragment up completely, but it will give me pieces of fragments. So I will get chunks instead of the actual individual ones. The fragments are formed, and these fragments are listed below. So 1, 2, 3, 4, 5, 6, 7, and 8 different fragments that they're giving me information for. It says Edmonds gives PTHLEU. What is the sequence of the protein? Okay, so first off, we've got to know what Edmonds does. And Edmonds tells me the very first protein or amino acid in the protein. And this Edmonds gives me PTHLEU. So that means the amino acid leucine has to go in the beginning. So I at least know one of the amino acids and the spot that that one goes in. I know where this is going to start. Now it's my problem to figure out how the other ones are going to follow suit. So you're probably questioning, well, how on earth am I supposed to do this if they only give me the location of one? Well, look at the beauty of what happens. So let's take a look at our fragments here, and let's kind of put our fragment pieces together. I know that my very first one is leucine. So my job in the next step is probably to go through these fragments and try to find leucine in one of the fragments. Because if I can find a fragment that has leucine in it, it will at least give me an idea of what else is supposed to come along with it. Okay, so I start scanning through and I try to find leucine. And here I find leucine, right there. And then I scan through, and I find another leucine that's here. And then here we go. So let's compare these two fragments that have leucine in them. In fragment number 7, we see leucine and only one other amino acid, and that's methionine, M-E-T. And then in fragment number 3, I see leucine as well as methionine as well as alanine. So this gives me kind of an idea of what else is near leucine. If this protein is being cleaved up into chunks, it's telling me what pieces are involved in the chunks. And what's good here is that at number 7, I know that there's only one other amino acid in that fragment, and that's methionine. So I know that methionine has to go here in spot number 2. So this leucine's taken care of, and the methionine's taken care of. Well, in fragment number 3, the leucine and the methionine are there again, and it looks like I've got a third amino acid that's tagging along. This will kind of give me an idea of what comes next. So there's alanine. So then I'll go through and maybe try to find alanine. Can I find alanine in another fragment somewhere? Well, I go through and I see fragment number 4 has alanine, and look, it only has one other amino acid, and that is glycine. So glycine will probably come next. So these two are taken care of. Now that leaves me with glycine. Let's see if we can find something with glycine in it. So I scan through and I look and find glycine here. And then right beside of that I see GLU. There's only 2 amino acids that come off in that fragment. So GLU comes next. What is the abbreviation for GLU? Hopefully you guessed it correctly. That is glutamate. Okay, so glycine and glutamate has been taken care of. Now I need to find glutamate. Can I find a fragment that has glutamate in it somewhere? Well, I do. I find one that's here, GLU, and I find one that's here, GLU. So there's 2 of them that are involved here at this location. Okay, well, I've got to figure out which choice would be better for me. Well, is there a fragment that also has glycine in it? And there is. There's one that has glycine right here. So I see glycine and glutamate. These 2 I've taken care of already. And it looks like proline is there. And then it looks like another proline is there. So that's kind of strange and weird, right? I mean, why would they list proline twice? And that's because this problem comes from your text, and there's actually a typo for this one. So if you're following along in the textbook, this extra proline, it's not really necessary. I don't really need that there. So what would come next would be proline. So let's write proline there, and that takes care of this one. Now, if I look at fragment number 5, I've already taken care of the glutamate and the proline. So what comes next is either serine or valine, and I've got to figure out, well, which one of these would come next if I had a choice. Take a look at your other amino acid fragments. If you look here at fragment number 1, a proline is there, and it's letting you know that proline and serine will come together. So here's proline. That means that serine will have to come next, and I've taken care of those. And look, proline, glutamate, serine, that means valine comes next. And then finally, valine is here, and what will come last is histidine. So there is the mind game known as primary sequencing. And we'll do another example in the next video, and we'll see that it's not really going to be any more complicated. It's just kind of getting a starting point and taking a look at all of these and kind of pairing them up. What was nice about this one is that there were no repeats. So that means that once you used leucine, you probably didn't see leucine throughout the remaining of the fragments. Once you use glycine, you didn't find glycine throughout the remaining fragment. Will all of them be that easy? Yeah, for the most part. They try to keep it simple for you. So that way, when you take a look at these problems, we can clearly define what order they need to go in without overcomplicating things too much. That's not what we're after. We don't want to do that. So there is the amino acid sequence, the primary sequence for the protein, and this is L, or leucine, methionine, alanine, glycine, glutamate, proline, serine, valine, and histidine. Now, I could do 3-letter abbreviations like this, or I could represent that protein with a 1-letter abbreviation. The 1-letter abbreviation for leucine is L. The 1-letter abbreviation for methionine, yeah, that's not complicated, M. The 1-letter abbreviation for alanine, A. 1-letter abbreviation for glycine, G. 1-letter abbreviation for glutamate, E, that's a weird one. Proline, P. Serine is an S. Valine is a V. And histidine is an H. So I could also represent the protein by just writing down the one-letter abbreviations. And we understand that this basically is a representation of the protein that I have there. Note that the one to the left represents the N-terminus and the one on the right-hand side represents the C-terminus. That is how we write the primary protein sequence every single time. We do the first one to the left and then we do the last one to the right. It's like reading a book, people. That is what we're doing here. So we'll look at another example problem. Stay tuned. If you liked that one and you thought that one was okay, take a look at the next one before you make up your mind.